What's the vision for 5, 10 years from now for how do we reassure the public when a new chemical is introduced and people are going to be exposed to it, that there's a reasonable expectation that that exposure level is safe. So the role organs on a chip are going to play in this, what I see, is that there's going to be a whole suite of these organ on a chip. Some for mimicking what happens for in utero development, some for adult organs in homeostasis, and then these all need to be tied together, right? Because it's important how the liver and the placenta and the thyroid gland and the reproductive organs all talk to one another. Now, is there going to be a one-to-one predictivity that anything that affects a particular organ on a chip is guaranteed to affect that organ in a human being? No, I don't think we'd ever get there, right? It's going to be an approximation. There's going to be a correlation, though. And so the organs on a chip serve as a means of prioritizing the chemicals. It's about being efficient in screening those 10,000 chemicals, and this is a good way to do the prioritization. Why that's important for the average person is because environmental toxicology is all about prevention. No one purposely exposes themselves to the chemicals that are in our environment. So suppose a company wants to introduce a new chemical into their product. I think none of us would be satisfied if we just took a completely wait-and-see approach. And if we look at the suite of tests that are available right now, they're not really satisfactory. You could go all the way to doing animal testing, and EPA has done that. They have decades of use of guideline animal testing on rats and rabbits. But rats and rabbits aren't people, and the effects that you see in a rat aren't necessarily predictive of what's going to happen in a human being. You can't do what pharma does and do a real clinical trial. No one's going to agree to take one of these environmental chemicals on purpose. They're not meant for human ingestion. It's going to be accidental exposures. And that's where organs on a chip come in. That you can take this system that uses human cells that mimics the in vivo environment of a particular organ, and it's that suite that has to be developed. That's why it's important to have multiple centers testing different kinds of organ on a chip devices, talking to one another, so that we can figure out how to connect them and put together the package of testing that would reassure the public that the introduction of a new chemical is not going to cause adverse effects.